Now, in the third example, we are going to use a function generator to provide the analog input to the system, and then we are going to use this signal to light up an LED. Okay, so in this function generator, you need to change the signal to sine signal, okay, because sine signal is the analog signal. You need to change it to the sine shape, and then with the frequency of 1000 Hertz or 1 kilohertz, and then the highest amplitude of this signal is 5 volt. The DC offset is the offset in between, is actually the middle offset of the signal. Okay, you put at 2.5 volt. Okay, then we need an LED. You might add a multimeter, okay, just to see the voltage output at that current state. So the positive port of the function generator, we connect it to the analog input of the Arduino board. Okay, you can choose any input. Okay, let's say you choose input A2. And then the negative port, you just connect to the negative or ground at the Arduino board. And then to see the voltage output here, you can connect this multimeter to your function generator or to your port. And then you take one digital output, any ports, to light up this LED. For example, in this case, I am going to use a PWM pin. Okay, so because we are going to use the value that we receive from the function generator, and then we are going to write the analog value onto that digital port by using the PWM function. Okay. And then the negative part of the LED, we are going to connect to the ground. Okay. So this one, we are going to configure to voltage. Okay. And then we are going to write our code. Okay, so now we are going to write our code. Okay, don't forget your LED, which is connected to pin 5. Okay, so after you have done, we can write the main function. So we're going to receive the input analog from this function generator. So I am going to save this data into a variable. We're going to use read analog function. Okay, and then this read analog function, and then this data, after we have saved it in the variable, so we're going to use this data to write this data onto the PWM pin here to light up the LED based on this value. Okay. So since you're going to write an analog value to the digital port, so we're going to use the analog write function, and then make sure that you have chosen the PWM pin for this experiment as your output that is connected to the LED. So we're going to paste this data here. You can give a delay to your system. Okay. So as you can see here, since the DC offset is set to 2.5, and therefore the highest value of the sine wave is 2.5. Okay, so okay, now we can add an oscilloscope to see the signal of our input. So the negative, you can put a common negative there, and then the positive, you can connect to the function generator. So we set the DC offset back. So now you can see the waveform is not fully captured, so we can choose to change the time per division. So this is the input to your system, okay, which is an analog input, and then you can see the value of this voltage is changing. Okay, you notice that there is the LED is not changing its color. Why? Your ADC is ranging from 0 to 1023 because it is 10-bit operation. But please remember from your previous class, the PWM is ranging from 0 to 255 because PWM in Arduino is using 8-bit. Okay, so since we have a difference bit implementation here, so we need to do some trick. So we are going to use the map function. What is a map function? So you can always Google to Arduino website to see how to use this map function. Okay, when you go to the map function in the Arduino, you need to read the description, okay, because you need to understand the theory behind this function. So according to this function, it is going to convert one value and to another value. We are going to use this map function to map the ADC value of 10-bit into the PWM value that is using 8-bit implementation. So from this map function, we are going to map the value from which source to which source. Okay, so here is the syntax. We map a value from low to low of the destination, from high to high destination. So our source is 10-bit, our destination is 8-bit. Okay, now we open back our coding. So we are going to map. So I am going to declare another variable which is 8-bit PWM. Sorry. Okay. So we are going to use the map function. So what value that we are going to map? So we are going to map this read analog value. Okay. And then from what source? From the 10-bit source. Also we start with the lowest value, which is 0, and then 1023. To what destination? The destination is your 8-bit PWM value. So you can write 0, the low value, and 255 is the highest value. And therefore, it will map this 10-bit to 8. So, by using the map function, your original data is from 0 to 1023. Okay, so this is your original data, which is obtained from the analog function. Now, by using this map function, you are going to convert this value to a new level, which is from 0 to 255, which fits the PWM implementation. Okay, because PWM in Arduino is the 8-bit data, while the analog ADC is 10-bit data. Okay, now we map, and then we are going to put the map value to our LED, and we simulate. Okay, now you can see the LED is illuminated because we have changed the bit implementation which is required by the PWM.